For our next section, we're going to take a look at inequalities in two triangles. So the first theorem that we're going to take a look at with this is called hinge theorem. It's a very, very simple idea. If you take the concept of a door, you can have a door that's partially closed, or you can have a door that is almost fully open. Okay, so if you're looking at this, the door and then the door frame are going to both be in equal length. Okay, so we call them both x. Then the width, or the space that's open between the door and the door frame, that we're going to call y. And then you can see that we can take that on a hinge and then we can open it up. And as we open up that angle right here, what you can see is that the length of the side that's across from that angle gets much, much longer. And so as nothing has changed with the length of the door or the length of the frame, they're still both x units long. But as we open up that angle, you can see that that third side gets much longer. So smaller the angle, the smaller the third side. Larger the angle, the larger the third side is going to be. For this first problem, we're being asked to determine which one of these statements is true based off of these two diagrams. So in this first diagram, you can see that we've got triangle SAK, and angle A is a 90-degree angle. Now, what you want to take notice of is that angle A is also the included angle between a given, or between a side that has a marking and between a second side that has a marking. So we're going to go over here and take a look at this triangle, and we can see that we have a marking, an included angle, and then another marking. So that means that these two angles, angle O and angle A, are going to be related to each other. That also means that side SK and side YU are going to be related to each other. So what we're looking for here is going to be some relationship between this third side and this third side. What we know by angle A being 90 degrees and angle O being 70 is that SK has to be greater than YU. So if you come down here, you can see that selection B is SK is greater than YU. So that is going to be our solution right there. And again, this is done because of hinge theorem. Since both of these two sides are congruent to these two sides, and this angle is larger than this angle, that means that this side has to be longer than this side. For problem number 2, you're given an illustration of a ride that many amusement parks have. In fact, Busch Gardens used to have one of these. It was called the swinging vines, and what it does is you get onto this basket that's down here on the ground, and then it raises you up, and then the top starts spinning. And as you spin, that centripetal force forces the basket outwards. So what this question is asking is, will you be further away from point A when you're sitting on the ground getting on the ride, or at time number 2 when you're actually on the ride and the ride is spinning? So again, this comes down to hinge theorem. What we know is that the length of the rope that attaches the basket to the tower is not going to change. So we can say that those two are congruent. Then we know that the side of the triangle that's created by going from point A to the point where the rope or the line is attached is not going to change either. So that's going to be a congruent part as well. So now what we're looking at is the length here versus the length here. And we can see that if we go up to the opposite angle, so for this one, again, it's going to be this angle, and it's going to be this angle right here for this one. The pink one has a much, much smaller angle than the blue one does. You can see that the blue one is at a much larger angle. So since the blue one is at a much larger angle, then that means that the blue side, or the third side that is blue, has to be much, much longer. And so that means that you're going to be further away from point A when the ride is in operation than when the ride is in load or unload. So for problem number 3, we're going to use the converse of the hinge theorem to determine what are the possible values of x for this diagram. Now, the converse of the hinge theorem states that if you've got two sides of two triangles that are congruent, and then the third sides are different lengths, so one side is longer than the other, then the triangle that has the longer third side is going to have the larger angle. Just as you learned that the larger angle equates to the longer side equates to a larger angle. So what we know here is that these two sides here are congruent because we had tick marks there. Then this side right here is going to be congruent by reflexive property. So now we've got two sides of two triangles that are congruent, and then we have the included angles that have been marked off. So that means that we can go to the third side and we can determine which angle is going to be larger by the converse of the hinge theorem. Since this side is 15 and this one's 10, that means that this 60-degree angle is the larger of those two angles. Now, in order to determine the range of possible values of x, what we're going to do is this. We're going to say that 60 has to be our upper limit. So if we have 5x minus 20, we're going to say that the greatest possible value that we could have there is going to be 60. But it's actually not going to be 60, it's got to be anything less than 60. So you can go ahead and reverse that and do 5x minus 20 is less than 60. So it cannot be equal to 60, it has to be less than 60. Now, on the other hand, to have an angle, we have to have a number that's greater than 0. Because if you have an angle that's 0 degrees, then you just have a straight line. So what that means is over here, we're going to say that 5x minus 20 is greater than 0, or 0 is less than our angle. Now, we have a complex inequality. All we're going to do is solve it like we would any other equations or inequalities we've ever done. We're going to add 20 to every section. So we're going to get 20 is less than 5x is less than 80. Now divide out this 5. So you get 4 is less than x is less than 16. So we know that our possible values of x have to lie somewhere between 4 and 16. In problem number 4, we're asked to provide a proof. In this case, we're given this drawing and this information. We're told that the length of BA is equal to the length of DE, and those have already been marked off with congruency markings. Then we're also told that the length of BE is greater than the length of DA. So let's go ahead and mark that off in some way. BE is greater than DA. So I'm going to mark this BE with the blue, and I'm going to go solid just to kind of let me know what I'm doing here. DA, I'm going to go with a dashed, and I'm just going to think of the solid as being longer and the dashed as being shorter. So what that now, and what I'm looking for to prove is that the measure of angle BAE is greater than the measure of angle BEA. So what we're looking for is to show that this angle here is greater than this angle there. Now, you might look at this and say, well, it's pretty obvious that the one on the left is much, much larger than the one on the right. But you can't trust the drawing is drawn to scale. So that means that you've got to go through and you've got to prove it. Now, what we know is this. If the length of BE is greater than the length of DA, well, one of the things that we can do is we can try to use hinge theorem, but we're missing one component of hinge theorem. We have that this side and this side are congruent, but we need a second side. The second side is going to be AE is congruent to EA, or AE is equal to EA. And so we can put that second congruency marking in there now, and now we can use the included angles. And this included angle is going to be BAE and the angle DEA. Well, what we know is that since BE is the longer of the two sides, that means that it's across from the larger of the two angles. So we know with assuredness that angle BAE is larger than angle DEA. So we already know that the large angle is bigger than this entire angle. So that tells us that since these two angles make up this angle, and this angle together is already smaller than this angle, then that means that angle BEA has to be smaller than angle BAE.